Hi everybody. Hi everybody. This is the third segment of the Mesozoic, and we just stopped the previous one at the New York supergroup, and we were talking about the rift basins. And this one starts with the fact that the Atlantic Ocean, after a while, have started to grow, and the eastern North American area become like a passive margin, and the rift basins, the sedimentation in the rift basins have started to cease, and the sediment, so this here is a cross section of this whole area around Baltimore, and so you can look at it and see that on the bottom of it you got these rift basins with some is graben, some is half graben, and the sediment filled up the rift basins, and then when they ceased to exist, then the sediment actually went all the way to the Atlantic Ocean. By the way, I already mentioned that the Appalachian have become completely peneplain, which means completely flat by the end of the Jurassic, and then during the Cretaceous it was a little bit uplifted, so there was some kind of mountain from which the sediment actually went straight to the Atlantic Ocean and created this so-called seaward wedge. So it's seaward thickening wedge, and it's about 300 meters thick. These rocks today are exposed in a belt which is expanding from Long Island all the way to Georgia, basically. So now let's move to the Gulf coastal region. This area was above sea level all the way until the late Triassic, when actually the Gulf of Mexico formed. And as I already mentioned, the Gulf of Mexico got a little bit of seawater. It became highly restricted, and I already mentioned to you that there was a huge amount of evaporate. Remember, evaporate is gypsum anhydride salt. So it was really, really thick, probably as thick as 1,000 meters, which is about 3,000 feet. So these evaporates actually made it possible for the geologists to study the so-called Great Salt Dome tectonism during the Tertiary, which is associated with really, really great oil formation. Not really the formation, but rather oil traps, formation of oil traps. So what's happening with the salt? What happens really actually that the salt, here is the salt. This is the first deposit in the Gulf of Mexico. That's salt. I just put an S. And then you got all the other sediment on top of it. But the fact is that the salt is much lighter than any other rock. So what happens as time goes on, actually, it makes a dome. It comes through all the other sediment. And what is interesting, it's nothing but salt. And the salt, when it's solid, impermeable. It's impermeable. So here we have all these other sediment layers in which the oil which formed in the Gulf actually is migrating, because most of it is sandstone, still some shale, of course, and the oil is always migrating in the permeable one, which is the sandstone. And when it reaches the salt dome, actually it got to stop because the salt is impermeable. So this is gonna be a typical oil trap. And we're gonna talk more about the oil trap during the Cenozoic, so that's what you're gonna learn more about it. Here is another salt dome, which is a more detailed drawing of it. So you can see that around the salt dome, above, everywhere. So the salt dome helps to form a lot of oil reservoir, and just the fact that it's moving through forms a lot of tectonic possibilities for oils to trap, like the anticline traps and the fault line traps. As I said, we're going to talk about this in the Cenozoic chapter. So that's about the salt. During the late Jurassic, this basin wasn't that restricted anymore, so the evaporate deposition ended. During this time, normal marine condition has returned, and cyclic deposition of sandstone, shale, and limestone started. During the early Cretaceous, remember that is the time when the sea level was about 200 meters higher than today's sea level, so this whole area got flooded. I mean, basically a Pyrex sea formed in this area, and deep ocean water, acidic sea, marine water have covered all this region during the Cretaceous. The reef formation have become pretty characteristic for this area, not really only the Cretaceous, but starting in the Jurassic, because it was restricted in the Triassic. So in the Jurassic, the late Jurassic is when the corals have started to occupy this area in the reef segments actually of this area. Now during the Cretaceous, the early Cretaceous, what happened, the typical corals of the Mesozoic, the scleractinian corals or hexacorals, have died out in this region, and they got replaced by actually mollusks, clams. These are the rudest clams, which were like the actors and actresses of the time, because even though they were clams, they behaved like they were corals, and they occupied the reef facies completely, and they actually were growing just like corals would. They had lots of porosity and permeability, so these are really amazing oil reservoirs, just like the corals would have been. And it's especially important in Texas. And this is how much you got to know about the Gulf region of the Mesozoic. Really, it's not that big deal. So you just have to remember the salt dome tectonics, that there is a lot of salt domes in the Gulf of Mexico, and then the cyclic sedimentation returns in the Jurassic, and then during the Cretaceous, where the sea level is really high, the hexacorals die out, and the reef area is going to be covered with this mollusk, the rudists. And now let's move to the western region. During the early Triassic, this region, because of the Atlantic on the other side, have started to open up. So North America was pushed to the west, and the western margin became an oceanic plate boundary. And as time went on, actually the island arc or the oceanic arc have collided into North America, and so North America gained a lot of land area right in the west. We know that these are allochthone because the geology of this area is different from the geology of the rest of North America. The subduction in this early phase was pretty steep, and the sedimentation in this region consisted a lot of shallow marine sandstone, shale, and limestone. During the late Triassic, the regression of the sea brought lower sea level, so the exposed areas of the former seafloor experienced erosion. From the eroded sediment, sandstone were forming. Spectacular example of this is the Painted Desert in Arizona. I don't know if you've been there. Because of the oceanic plate boundary, actually there was a lot of volcanic activity, and in the Painted Desert and the petrified forest area, the trees become silicified from the volcanoes, and that's how we have them actually completely preserved. I have a slide, I know, which coming up. This is the area we're talking about, where there was a lot of, during the Triassic, it was still part of Pangea, so a lot of very, very continental sediment have formed, mostly wind-carried, cross-buried sandstone, red sandstone, which actually characteristic for very continental, very dry climate. So we have, as I just told you, these are the formations: the Mancofi, the Sinarum, the Chinle, the Wingate. You do not have to know this. I will not ask, so don't worry about memorizing. Swear. If you did memorize it, that's okay, because then you can use it as extra credit. There is a place called Sedona. Actually, this here is a picture from Sedona. There is three more formation which you can see here. Actually, on this slide, they showed the Chinle, the Navajo, and the Kenota formation. So anywhere you go in that area, you will see these formations just about everywhere. Like you see, this is the Arches National Park, Canyonland, and Sedona. As I mentioned, Sedona is really beautiful. If you ever have the chance to go there, do it. This is like a perfect honeymoon place. Like every room in Sedona has this view. It's pretty amazing. Of course, Arches, like it's like right next to Moab. It's really amazing too. Arches National Park, the arches are all formed by Sodom tectonics, so it's really, really cool and interesting. So if you ever go there, Arches or Canyonland, you will remember me, no question. There's another place, the so-called Dead Horse Point State Park, Dead Horse. And I already kind of mentioned it to you during the Paleozoic Dead Horse. Dead Horse Point. Some horse died there, that's why they call it. It has nothing to do with today. It was a long time ago. And this slide is about the petrified forest. So these are the fossilized trees, and I said it was silicification from the volcanoes of the oceanic plate boundaries. The Navajo sandstone, which is late Jurassic, early Jurassic, has really, really large scale cross-bedding. As I said, that just means that everything here was deposited by the wind, and dunes were moving around, just like you would go to Death Valley today and see all those sand dunes, or Oregon. There's a lot of places out there where they have active sand dunes today. This place right here, if you ever have the chance, go to see it. It's called the Waves. It's really beautiful, Waves. And it's between Utah and Arizona. So just look it up. Only 20 people a day can go. It's really, really, really amazing place. This here shows you the Mankope Formation. And right here, in the middle Jurassic, there was a sea which came on land, and it's called the Sandus Sea. It's right here. And the bone, in this sea, there is a lot of bones from Jurassic marine reptiles, and it's very characteristic in this formation. After the sea regressed, it left behind a swamp area, basically, and this is the time for the so-called Morrison Formation. The Morrison Formation has a lot of dinosaur bones, so therefore this here is the most famous formation, and the Dinosaur National Park is also a Morrison Formation. So I kind of want you to remember the Morrison Formation. It was like a swampy deltoic sequence, and the dinosaur was actually formed by dying into a flooding river at the time. So it's like 50 complete dinosaurs which died into this flooding river, and it's shown in the Dinosaur National Monument, which is northern Utah, close to the Four Corner region, really northern Utah. And right here is the dinosaur fossil in the Morrison Formation. So please remember the Morrison Formation, because most of you like dinosaurs, so that's the only formation I kind of want you to remember. And this is the Mankope, and I messed up the Morrison Formation. I guess I'm just gonna finish right here and go to the next segment. So I'll see you there.